Today we are starting trigonometry, so our goal is to be able to use trigonometric ratios, or trigonometry ratios, to solve for a missing side on a right triangle, right? Good. Let's fill in these words. We have these definitions that we've definitely heard of before. Hypotenuse is the side across from 90 degrees. So when we did Pythagorean theorem, we were labeling C as our hypotenuse, so we know how to identify a hypotenuse. And then we have this word adjacent. What does adjacent mean? It means next to something. So if I think of like this hallway, Miss DeLuna is opposite, across the hall, but Mr. Locke is next door. Mr. Locke is adjacent. So literally a next door situation. So this adjacent side is next to, and we're going to use this new symbol, theta. It looks like a 0 with an extra little line in it, okay? So again, that's called theta. And it is a Greek letter, okay? It's a Greek letter. It's kind of like X. We're on the front side. So theta stands for a missing angle. So you see it right here. So let me spell it for you. This is called Theta, theta, Greek letter. If you're familiar with college fraternities or sororities, they use Greek letters, right? In fact, there's a math club on campus called Mu Alpha Theta, and if you look at their logo, it's got a theta in it, okay? So anytime you see that, that just means a missing angle, and we're going to use that more on Monday. Question. Delta is a Greek letter. Actually, pi also is a Greek letter, and it stands for the ratio of circumference to diameter. When we get to circles, we'll talk about pi. And by the way, coming up in a couple months is going to be Pi Day, 3/14, right? But it's always during spring break, so we don't get to have any pi at class. But, dang, I'm sorry. All right, opposite side is, spoiler alert, opposite. All right, so you get the idea. Opposite of what? Of theta, okay? So, those are your three sides that we're going to use, all right? And so, we need to know the ratios. Now, we need to be able to write kind of small here. So, let's do that. Go a little thin. For S-I-N-E, okay? I say this as sine, okay? It's not spelled the way we spell S-I-G-N, okay? But it's S-I-N-E, okay? So, did you know math has gang signs? And you can graph a sine, and it looks like this. Whoop, whoop, whoop. So it's literally like a wave, okay? I actually had a shirt that said gang signs, and it was a guy spray painting a mathematical sign. It's funny if you get it, but none of y'all are laughing, so it's okay. But sine is one of them. Then we have cosine, and then we have tangent. Now, do y'all know what a tangent is? Not a tangerine, but it's what happens when a guy is out in the sun too long. He's a tangent gentleman. Tangent. Get it? All right, well, anyways. So let's actually write this down. Sine is going to be, write small, opposite over hypotenuse. Opposite over hypotenuse. Or just O over H. Okay? So sine is opposite over hypotenuse. And what we're going to do is we're going to say these three letters as a word. So S-O-H is what? How do you say that? So. Okay? Now, do any of y'all know what a haka is? Haka. So you might be able to find a few YouTube videos of these. It's like, I think it's Hawaiian. But it's these, I'm not going to pull it up. It's guys who basically like scream and make crazy faces and like, ah, all right? You may have seen it before. But I'm not going to do the whole haka. We're going to do a pseudo haka, okay? So when I say S-O-H, I'm going to say so. Haka. All right, so y'all want to do it with me? 1, 2, 3. So. Haka. No, that's, you want to say so. So. There's one. All right, so. I can hear you. All right. Well, anyways. Okay, there you go. So cosine is going to be adjacent over hypotenuse. Which is A over H. So I know it's kind of a lot, it's kind of small, but write it down, okay? You got this. Write down. So SOH, now we have CAH. So how do I say CAH? What is that? Just say it once, don't say it twice. The second one. CAH. Ka. Okay. No, don't say it twice. All right. Now, y'all ever wonder why I have long hair? Because whenever we start talking about trigonometry, I go, ka. Yeah. All right. It's the so, ka. Mea. No. Okay. Anyways.
Tell me why you have long hair.
Because when I go next level, my hair goes spiky. You know what I'm saying? You know what I'm saying? You know what I'm super saying? Okay. All right. Last one. Opposite over adjacent. So that's going to be O over A. TOA. You finished? Turn in. So Toa. Any y'all ever play with Bionicles? Those little Lego things? So Toa was like something in the universe of Bionicles. It's a Lego thing. If you don't know what it is, it's whatever. But, so we have three funky words. So, ka, Toa. So if I'm going to do the haka, it's so, ka, Toa. So Katoa. Now, so Katoa sounds like soak a Toa. That's kind of weird, but here's how you can help remember this. I have a true story about Mrs. Marrero, right? So did you know, you may have seen this last year, that Mrs. Marrero was walking down her driveway, and she stepped on a pecan, and she slipped, and she actually broke her foot. True story, right, Miss Marrero? And then you may have seen her like pushing around a little cart, or what was it? A knee. Oh, never mind. It's been almost 2 years. Real quick. So, let's let Miss Marrero tell the story.
I was in my driveway getting mad at my son because he wasn't doing what I asked him to do. I turned around fast and was going to yell, but I slipped on a pecan and my foot went out, my ankle, and I couldn't walk after that. So I hobbled over. He had to drive me to the emergency care people. I was in pain, severe pain, like, oh, I can't walk. And so I went to the orthopedic surgeon who said surgery, and then he put a pin in my foot. And then I was running around a knee scooter for 2 months. All the principals wanted to drive it. Mr. Poole thought it was a skateboard. And I know, Mr. Poole. So then I could not bathe because it couldn't get water in the stitches. So finally when I could, then I could sew Katoa.
So Miss Marrero at the end of the day was able to soak her toa. All right? So, soak her toe. Because she literally was able to soak her toe. All right, when you stub your toe, you got to soak your toe because it hurts. That's it. Bottom line. Like when you walk on my math class late and you stub your toe because you're not on time, that's what happens. Soak your toe. All right, well, anyways, story's over. Now, ready? We got a challenge. You like challenges? Whether you like them or not, I'm going to challenge you, right? So you know what opposite means, right? If I start at an angle, you know how to, you're going to put an O across from the angle, right? And you know the H is across from what angle? 90. And then the A is your third angle. So looking at this picture right over here, I want you to start at P, and I want you to label O, H, and A in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, now everyone did it, right? But I'll help you do it, okay? If you didn't get it, I got you. Here's how you do this. Is everyone looking? From P, I'm going to label an arrow that goes across. And what am I going to put there? I'm going to put O. Okay? It is C when we do Pythagorean theorem, but we call this the opposite. Actually, it's not even C. C's across from the 90. Okay? So this is called opposite. Okay? Now, I'm going to draw an arrow across from the 90. That one's going to be called H for hypotenuse. Okay? And what's my leftover? A. So every time you do a trig problem, my suggestion, label O, label H, label A, and then the rest is going to be just making fractions. Because these are all just ratios. Okay? So here we go. I want to do sine P. Okay? So sine is so, which is O over H, right? So, student, can you tell me the sine of P? What's O over H? O is 16 over 20. Very good. You just make a fraction with the numbers of O and H. So 16 over 20. Very good. And then reduce that fraction. I'll help you out. It's 4 over 5. Do you see how I did that? All right. Student, can you help me with cosine? So what's cosine is ka, which is A over H. What's A? Well, there's a 1 there. 12 over 20. So cosine is 12 over 20. That reduces to 3 over 5, yes. All right. Student,
Yes.
can you do tan? So tan is Toa, O over A. What's O and what's A?
O
What number?
and A is 12.
Okay, so what's 16 is next to O. What's next to A?
O 12.
So 16 over 12, right? So 16 over 12 is reducing to, which is 4 over 3. So, moving on to sine Q. Now, I want everyone to notice. These three had what letter here? What angle? P, right? Look with your eyes, right? What letter's here? Q. So let me tell you, if the letter or the angle changes, your O and your A have to change. Okay? They're just going to flip, correct. So watch this. If I started at Q, what's my new O? 12, right? So now O is over here at 12. H never changes. I'll say it again. H never changes because the 90 degree is never going to move, right? So my O is here now, and now my A is down here at 16. So, HOA. So what is the sine of Q? So help me out. Sine is O over H, right? So what's O? And what's H? Thank you for writing this stuff down, right? So 12 over 20 reduces to 3 over 5. 3 over 5. Okay, so help me out. Cosine is what over what? A over H, which is what over what? 16 over 20, which reduces to? It is 4 over 5. Writing the stuff down too. All right, so let's do tangent. No, tangent is what over what? Yes. Tangent is what over what? No. You. You. O, what is O over A? What's O? Over. Okay, so 12 over 16, which is what? 3 over 4. Okay, so do you see how we do that? You have to label OHA, and you have to make the right fractions, okay? Now, let's try this one again. Is everyone with me? I got a new triangle down here. I'm going to start at angle what? A. So I'm going to give you 5 seconds to label O, H, and A. 5, 4, 3, 2, 1. So, have you labeled O, H, and A starting at angle A? Okay? Stop. So, starting at A, what's across? So what my O is going to be 15. My H is going to be across from 90. Very good. And then A is left over. Now, let's do it again. Okay? Do you want to help me do this one? So what's sine? What over what? Okay, so here's what we got notes. So sine is what over what? So you tell me, what are the numbers for O and H? Whoa, 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 whoa. 15 over 17. Okay? Thank you very much. So, help me out here, unnamed student, since we don't say names out loud. Tan A is what? Okay, so it's Toa, O over A, 15 over 8, right? Okay, that's what it should be. So remember, every time we do tangent, or were you answering this one? Sorry. I skipped down to 3, my bad. Okay, so, but tangent would be O over A, so 15 over 8. So my bad for going out of order. So let's backtrack, okay? So cosine. What do we think? Cosine is what over what? Ka. So that's what over what? A over H. So it's going to be what over what? 8 over 17. Okay? Please don't talk. You too. Thank you so much. Especially you. Okay, number 4. So what's different about number 4? What changed from 1 to 4? Okay, does everyone see the angle changed? Now, we just talked about this. When the angle changes, what's going to change? Okay, O and A. Now I'm going to start at C, so my new O is going to be here. So my new A is going to be there. All right? So now let's do sine C. Okay? So, let's get someone who's definitely not paying attention. All right, help me out here. O over H is going to be what? So, from C, we just labeled them. So, O over H is sine. So, what over what? Oh, O over H. 8 over 17. Very good. Now, these don't reduce. That's why we're leaving them like that, right? So, all right. So, cosine is ka. AH, so 15 over 17 is correct. And then tangent of C, Toa, okay, is O over A, so 8 over 15, right? Now, how do y'all feel about trig ratios? If you can remember so, ka, toa, then and if you can label O, H, and A, then you can make a fraction. All right, so now the next part might be a little easier because we're going to do some calculator. Everybody needs a calculator. Okay, so you can teach her this when she gets back, I guess. Okay, so everyone needs a calculator, and I want you to press on. So we're pressing fingers onto buttons because I'm going to show you how to use this yellow calculator. Okay, so if you press on, you have to make sure you're in degrees mode. Okay. So I'll show you. I need everyone pressing buttons here, okay? So I want you to hit settings. What number is settings? 5. So everyone hit 5. No. 5. And then we want to go to document settings, which is 2. Okay? The reason why we have to do this is because you will not be able to get the correct answer unless you're in degrees mode. So the second thing that says angle, it says, hopefully yours says degree. But you want to always check, or you want to know how to fix it if it's not right, okay? So again, it's 5, 2, and then you make sure this is degree, and you make default, and you're good, okay? Fix it. So if you go to a new document and you don't save, at the top it should say DEG for degree. It should not say RAD. Okay, we're not doing radians. So again, it's 5-2 degree. Now, we are going to use these trig ratios, and I want y'all to notice. It says SIN. We say the word sine. You don't have to say sin, because this is not a class where we talk about our sins, right? So we're talking about sine. And when you see tan, we're not talking about catching some rays. You know, we're talking about tangent. And when we say COS, we're not talking about cos, because we don't say cos words, right? We're talking about cosine. All right. So sine 30. Where on this calculator do you see a sine button? Spoiler alert, there is none. But there is a place for trigonometry. All the trig is in one button, and guess what it's called? Trig. So I want everybody to press the button next to the number 7 that says trig. Okay? Right next to the number 7, you want to press trig. And we're gonna click sine 30. So everyone needs a calculator. You did. You got pilfered. Sine. And we're going to press sine 30. So we press that, we type 30, we hit enter, and we get 0.5. If you get something else, you're not in degrees mode. 0.5. Sine of 30. So we write that down. And now we do the next one. Tan 45, tangent 45. So let's go to the trig button. Tangent 45. You should have 1. What? Are you doing this? So listen. So you press this button next to 7, trig. And then we're going to hit cosine. And then we're pressing 60 degrees, cosine 60. And we get 0.5 again. Okay? Is everyone able to, in their calculator, press trig, pick the button, press the numbers? Okay? So maybe that was not too hard. Okay? So we're going to combine both of all the stuff we learned on this sheet so far to find a missing side. So this is where we're actually going to see the trigonometry solve something. So look at the bottom here. I'm going to give you 3 seconds to label O, H, and A from angle 55. 3, 2, 1. And some of y'all just stared into space. Welcome to class. Don't stare at me. So it should be very easy to label O, H, and A. You have to pick up that pen, though. You know what I'm saying? So here we go. From 55, did you label O across, H is across from 90, and A is down here? Okay, that should be the easy part, right? O, H, and A, right? Now, when you do this on a problem like this, you need to figure out which one do I not need. So look at O, H, and A. Which one has nothing next to it? Okay, H has a number, O has a variable, but A has nothing next to it, right? So if there's nothing next to it, I can't use it. I mean, what number would you put there? I don't know. So cross out A. We don't need it in this problem because there's nothing there, okay? So we're labeling that. So the one I'm going to use has O and H in it. So I'm going to rewrite my so, ka, Katoa. Know what I'm saying? So Katoa. And which one of these 3 has O and H in it? S, right? See, if I can't use A, then I can't use tangent, because that's an A. I can't use cosine, because that is an A. I have to use S, sine. Okay? So that's how you figure out what you're going to use. Too many people ask me, Mr. G, what am I going to use? Sine, cosine, or tangent? Well, you got to look at what they give you. Whatever they give you, tells you what you're going to use. Okay, first question. Where did this come from? The reason why this is a thing is if you have a missing side, and you know one angle and one side, and a right triangle, you can find the missing side. So it's useful for that. Now the other question is this, are you going to be like stopped on the street and asked to do this? Probably not. But there are professions where you use this. And you definitely have to use it for geometry this year. So let's do it. All right, so SOH, so let's do sine. So let's write the word sine, the abbreviation. Sine. And what angle are we using? What angle are we using? So on the inside there I see 55. So sine 55 equals, and now I put the fraction. What over what? So it's O over H. What's O? X, and H is 25.5. Do you see how I set that up? Sine, angle, equals fraction. Okay? Now here's the problem. X is not by itself. X is being divided by 25.5. How do I get rid of a divided by 25.5? The opposite of dividing is multiplying. So here's the deal. When X is on top, you're going to have to multiply by whatever's on the bottom. If I do it on one side, I'm going to do it on the other side. So these 25.5s cancel out. Now I just have X equals. And what's left over is your calculator problem. Okay? All I need to do is type in the calculator, sine 55 times 25.5. Okay? If you're writing on a phone, you should be paying attention to notes. So let's type this in our calculator. Sine 55 times 25.5. So let's go to trig. Sine 55. Please don't forget to end the parentheses. And I want to see everyone typing this in, okay? Because we're pretending like this is easy, and I know y'all aren't going to understand this. You're writing on the back of the phone. Times 25.5. So sine 55 times 25.5. We hit enter, and we get 20.888, and that third 8 makes the second 8 go up to 9. So 20.89. And I'm going to write it over here on this blank, 20.89. So, again, I labeled my sides. I crossed one out. I wrote my trig, and I solved for X, and then I plugged it in the calculator. Those are my steps, okay? So let's look at this one over here off to the left. So I'm going to kind of divide this. Now, the one on the left, X was on top. Would you know what to do if X was on the bottom? Maybe, maybe not, but that's why I'm going to show you what to do right now. Okay? So, I'll give you 2 seconds to label O, H, and A. 2, 1, 0. Oh, you didn't even try. So, from the angle, we label opposite, hypotenuse, and the third one is A. You actually have to be able to do this on your own, so you should try it when I ask you to try it, right? So, O, H, and A, we look at those 3 sides. Which one has nothing on it? A. It's not always going to be A, but on these 2 it was A, right? Now, OH is my so. It's my sine. If there's no A, I can't use cosine or tangent. So let's write it. Sine, what's my angle? Sine of 60 equals, and then we're going to put what over what? O over H. 10 over X, okay? Now, does everyone see how that's kind of weird because X is on the bottom? But that's correct. X is on the bottom in this situation. Now, we can solve this the long way. where I tell you 2 different steps to get x by itself? Or would you like a kind of a shortcut? Okay, I'm glad. So we're going to do the shortcut. All right, if x is on the bottom, here's the little trick. It's a mathematical trick. It's like this. You have to leave the class twice in one period? Sure. You're going to know trigonometry. That's for sure. So, ready? Woo, woo, woo. Woo, 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 woo. But here's the real trick. If you have this right here, and this right here, if x is on the bottom, you can just switch them because of mathematical steps I would tell you, where you divide and you multiply. Just take my word for it. When x is on the bottom, just take what's on the left side of the equal sign and switch places. So x goes to the left, x equals, 10 is still on top, and on the bottom I'm going to write sine 60. Okay? Does everyone see what I did there? You just swap the left side of the equation with the denominator, the bottom of the fraction, because if you multiply by x on both sides and divide by sine 60 on both sides, they're going to end up switching places. But not if it's on top. Very good. So again, when x is on bottom, switch it with the left-hand side. Every time. So let's go ahead and type this in the calculator. 10 divided by sine 60. 10 divided by sine 60. And I get 11.55. That 7 makes the 4 go up, right? So 11.55. Hold on. Yes. Real quick. Real quick. So 10 divided by sine 60, and the trick is if x is on bottom, just switch places and then type in the calculator. Okay? So that's sine. So remember, up here, we should have done this earlier, sine is O over H, right? Okay, so flip it over. Let's do the top part of the next page. Cosine equals, okay? Now, we know C is ca, C-A-H, right? So we're going to put A over H. So I'll give you a whopping 1 second to label O, H, and A. Do it now. 1. You're done. All right. So across from 55 is O. Across from 90 is H. And then we got A. Cool. Now, which one am I not using this time? Does everyone see O is all by itself? I don't need that in my life right now. Okay, so we're going to cross it out. So the only 2 I have is A and H. Now let's remember, so Katoa, so Katoa. Which one is AH? So is this AH? Okay. So C is going to be the AH. CAH, right? Ka. I can't use so because that has an O. I can't use Toa because that has an O. I got to use Ka. Cosine. Do you see how I have to use cosine? There's no other option. So let's write that. Cosine. What's my angle? $55. Okay. So cosine 55. And that's going to equal what over what? So my adjacent, my A is what? So what's my A? What's my H? Stay with me. X over 25.5. Now, X is on top. If I want to get rid of a divided by 25.5, what's my rule? What's the opposite of dividing? Multiplying by 25.5 on both sides. So times 25.5 to cancel that out, times 25.5 on this side. That leaves me with X on the right. And now all I have to do is type it in the calculator. Cosine 55 times 25.5. Let's do it. Cosine, what is it? 55. in the parentheses times 25.5, which gives me 14.63, because that 6 makes the 2 go up. So 14.63. And that's my missing side. Okay, label O, H, and A on the next one. Make sure you're following along. So I got O, I got H, I got A. Which one am I not going to use? O. So cross out O. I have to use AH, so that's going to be cosine, ka. My angle is 65, and that's going to equal what over what? What's A, what's H? Well, A is 21 over X. Now, we said if X is on the bottom, we got a trick for that. And the trick is swapsies with the left side, right? So I'm going to take the cosine 65 and the X and switch places with them. So it's really going to be 21 over cosine 65. And now it's just a calculator problem. So let's type that in. 21 divided by cosine 65. That gives me 49.69. The 0 does not make it go up. So 0.69. All right, so that was 2 more examples. Those were both cosine. So guess what the last 2 are going to be? Tangent, right? So, if we can knock these out, tangent is Toa, right? O over A. Now I'm going to label both these triangles in 5 seconds. Let's see if I can label O, H, and A. Ready? 5, 4, see how I'm doing all slow? 3, 2 and a half, 1. All right, and 0. It's actually hard to count and write at the same time, TBH. It's also hard to draw an O. Anyways, here we go. So all that to say, I've got everything labeled. Which one am I not going to use this time? Does everyone see? H has nothing next to it. So cross out H on both of them. No H, no H. So Katoa, which one is going to be OA? Toa, tangent. So let's do this. Tan 58 equals what over what? X over 9. How do I get rid of it? Divided by 9? Multiply by 9. Times 9. Cancel, cancel. Times 9. Tan 58 times 9. Tan 58 in parentheses times 9. 14.40. So that's just 14.4. And then over here, OA is still tangent. So I'm going to do tan. The angle is 24. And it's going to be O over A. So it's going to be what? 41 over X. Question. Switch what? No, because you're starting at 20. You always start at the labeled angle. That's how, yeah, 41 is O. Very good question. So our trick is we switcheroo when X is on bottom. So X is 41 over tan 24. And we go to the calculator, 41 over tan 24. What is it? 24. And we get 92.09 because the 7 makes the 8 go up, right? 42.09. Sorry, I'm saying things wrong. 92.09. And somehow this class got through all the notes. It's great. So, we did all of trigonometry. We haven't done inverse trig. We'll do that later. But on Monday, we'll have an assignment on this. But keep these. Remember, so Katoa, OHA, set it up, solve for x.